Hey everyone, I hope you're doing well. This is our third lesson in our financial applications unit. This is actually the last lesson in this unit, really short unit. And we'll have it just a short test, so like a half test. So 30-minute type deal that'll be based on these three lessons, and we'll talk about that more in class. So before we get into this last lesson, let's just do a warm-up from last class. So I would pause the video and try out these three questions. You've got kind of things filled out already for you on the screen, but try these out, see how you do, and I'll go through them. Okay, so the first one says Mr. Armstrong deposits $4,000 at the end of each year to account paying 5.5% per annum. So this A is just annum or yearly. Compounded annually, determine the amount of the annuity after 6 years. So annuity, remember, means that there's been a regular payment or withdrawal. So something with regular in it. So it's happening at a regular interval. In this case, we have $4,000 going in at the end of each year. So that becomes our payment. And remember, if you're giving it or someone's giving it to somebody else, then that's going to give it a negative value. So when you punch it into the TVM solver, remember you go to apps and then finance, and you should find it there. You want to put these things in as you see it. We have 5.5%, and it's just compounded annually, so we don't have to divide or multiply N and I. We can just leave them as they are. So if you punch this in and then you put alpha solve on FV, then you get, I believe, 27,552 and 20 cents after 6 years. So nothing left to do. We just need to punch it in and put the appropriate stuff. So the next one, Miss Holman is saving to go on a trip to South America and needs to have $5,000 saved up in 2 years. So she needs that amount in the future. So that's why my FV here is 5,000. And it's 2 years. Her bank gives her 6% per annum, compounded monthly. What's the monthly payment? So we're looking for payment. And so because it's compounded monthly for 2 years, then we need to do 2 times 12. And then we also need the interest rate per month, so we have to divide by 12 there. So again, those two numbers are always going to be the same. And just a reminder, I didn't say it in the first question, but PY and CY will always be equal to 1 in what we're doing at least. So then if you press alpha solve on payment, in this case, the payment is a negative number because she's going to have to make that payment. And that's okay. You just know that she's giving that payment. She therefore will have to make a payment of that amount every month. Like that. And then the last one's a bit trickier. There's an extra step at the end. If we read through this one, it says you want to save money for a car. You decide to put 50% of what you earn into an account, earning 5% compounded monthly. If you work 10 hours a week and you make $15 an hour, which is almost minimum wage, slightly above, determine around how many years it'll take for you to have $20,000. So there's a few things going on. We need to figure out how much we're actually working so we can get 50% of that. So let's start there. So we've got 10 hours a week times $15 per week. So that means we're going to be making $150 per week. And so if we want to determine how much we make in a year, we're going to multiply that. We're going to take 150, obviously, and multiply by the number of weeks in a year, which is times 52. So give you an idea of how much you're going to make as part-time employee, which comes out to $7,800, and that's per year. And so doing that, and we could have done this slightly different, but just to give you an idea, that's how much it would come out to per year. But we do need to get this in per month because it is compounded monthly. So the last step here is to just divide this by 12. Because we've got 12 months. So if I do that, I get $650 a month. And the last step, we need to 50% of that. So therefore, I'm going to divide that by 2, so that's $325 per month. So that gives us our $50 or 50% of what we earn. That's the thing that I put in here for payment. And so you could have done that slightly different if you wanted to figure out the problem by if I took $150 and if I tried to multiply that by 4, that would come out to $600. The reason it's not the same as what we got here per month is because there's actually more than 4 weeks in a month. And so we had to put it into a 52-week thing or per year and then divide that by 12. And that gives us per month. And so in the end, we got that negative $325 that we're going to make as a payment. So that's our savings. So we're putting it into account, and that's why it's negative. Determine how many years it will take for you to get $20,000. So my FV is $20,000. My interest rate was 5%, and it's divided by 12 because it's compounded. And so what we're going to solve for here is n. So if you do this, punch all that in, and then you get your alpha solve on n, what we get is n equals 54.8, and that's always going to be whatever the compounding period is. And so it's basically given us that in months. And so if we want it in years, we need to divide by 12 for years. So if you do that, you get approximately 4.6 years. And you can always think about this logically after you've gotten your numbers and say, okay, I got an answer, 54.8. That seems like a lot of years. Well, that's because you're in the wrong units. So then in the end, if you think 4.6 years, does that make sense? If you're putting $325 every month, yeah, that's probably going to make sense. So in a year, $325, you're going to be almost $4,000 a year. That would be almost 5 years, but you've got some interest going on it, so it's less than 5 years. So it's good to always kind of reason out what you've got going on. Okay, hopefully all of that's okay, and we can go through that in class as well. So this lesson today, we're going to look at what's called the present value of an annuity. And this really has the biggest applications in a few really specific things. One of them being, for example, a mortgage, like how much you're going to have to pay per month on a house. Or let's say you've saved your retirement money and you want to know how much you can take out of your retirement fund each month or whatever the interval is for the rest of your life, basically. There are a couple other things like an endowment, which is something you might have heard of, and that's like the school has a small endowment, which is a lump sum of money that they use to for financial assistance. And that money is invested, and so the money is always making interest or gains if it's in a stock market or something like that. And so that money can be used in order to give money out in endowment or in tuition fees. So there's this interesting lottery game, you might have heard of it. It's called Cash for Life. And it's promises here, lottery game, that if you buy a ticket for $3, you get a chance to win $1,000 every week for life. I think it's actually up to $4 now. Not that you need to know that, but just in case you're turning 18 soon. This is a situation where the lottery corporation can make a lot of money. And if you think about it, so all these people pay $4 or $3 to get a ticket to get this gain. And then the lottery promises to pay you $1,000 a week for life. And when they say life, sometimes that means 25 years. It's like a jail sentence. It could, in some cases, they've changed that, so it could mean that it's in your entire life. But there's an advantage for the lottery corporation here, and this is kind of like the present value of an annuity. So all of those ticket sales, 4 times, let's say they sell 100,000. So you've got their $400,000, and they can take that money, and rather than paying it out to somebody right at the beginning, they can invest that money and then pay out $1,000 every week. And while they're paying that out, all of the money that they haven't paid out will continue to make more money for them. So it's an appealing thing because people like the idea of, getting money on a regular interval, but it also works for the lottery corporation because they get to make money on it as well. So in this kind of situation, it's often important to determine how much your regular payments will be in order to pay off a loan, or like in this case, the lottery game is kind of like a retirement savings. How much can you withdraw from that? It's also important to understand how much money you will be able to withdraw when you retire. And this is the kind of thing I helped my parents with when they went to retire. So it's maybe something you might end up helping your parents based on this. And I was talking about an endowment. And if you, there's an article here you can click on if you go to the general content section. But Harvard's endowment is now $40 billion. And $40 billion means that they pay a whole bunch of money out to not only students, but their faculty for research. They've got basically have enough money that most people wouldn't even need to pay if they didn't want to go to school. But this is an interesting article. If you click on it, you can read about it. It's Harvard has the largest endowment at 40 billion. There's some that are around 30, 25 billion. So it's a lot of money that they get to just make money off of and never really hopefully have to worry about not having money for their school in the future. Okay, so I'm going to just talk briefly about the idea of this present value of an annuity. So again, imagine you have, you want to know how much you need to invest right now. So I'm going to look at this example here. Let's assume your parents want to invest a sum of money so that you'll be able to withdraw $1,000 each year for the next 5 years. So rather than saying, okay, I need to put into the bank $5,000 because 5 years times $1,000 would be $1,000. I was thinking, what if we just put that money into the account now? Then we wouldn't have to invest $5,000 because we could be making enough interest in order to give the $1,000 out, and it would be somewhat less than $5,000. So let's say they earn 5% per annum compounded annually, and the following diagram kind of looks at how you would calculate what you need now based on that. And so as it turns out, so you want to find out how much you need right here. So this is my present value. And we don't really know the future value, and we're not too concerned about it because by the end, what's going to happen is when I'm done taking out 1,000 every year, this is going to be a value of 0. Because imagine you're in retirement and you want to take all your money out. You don't want to leave it in your bank. You want to take it out and have nothing by the end. So in this case, it's $1,000 a year. And here's the calculations, which actually is the same formula that we looked at with compound interest for present value. So it takes your future value, which is $1,000, divided by 1 plus the interest rate to the exponent of how many years it's been in. So in this case, it turns out that they need to invest now $4,329.48 in order to pay out $1,000 each year. So you can make money in the meantime. And so that's kind of the idea that's going on here. So here's the formula, but you are going to use your TVM solver to help you here. But the formula here, very similar to the FV formula, only now we've got present value. And my R, remember, is my regular payment or withdrawal. And we'll just say regular payment. I'm going to put in brackets PMT because that's what it is on the TVM solver. And the interest rate is the interest rate per compounding period. And N is always our total number of compounds. And generally, or most of the time, it's going to be years times the compounds per year. occasionally, if you're less than a year, it might be something slightly different. Okay, if we look at an example here, it says calculate the present value of an annuity which will pay $750 every 3 months for 5 years at 4.5% per annum compounded quarterly. So let's write down what we know. So we've got a regular payment. And it's every 3 months for 5 years. So every 3 months means 4 times per year. So we start writing down what we know R, or PMT in this case, is going to be 750. Oops. And when we use this formula, we don't have to worry about negatives and things like that. That's only in that program. And then N, which is the number of compounds per year, is going to take my number of years, so 5, times the compounds per year, which is quarterly. So I got 5 times 4, so that gives me my N. And then I is going to be my interest rate as a decimal, so 0.045, and then I have to divide it, so it's per quarter. So divide it by 4. So then I get this number. So I keep saying it, but whatever I multiply by for N, I need to divide by for I. So logically, you're thinking, I need my interest rate per compounding period, so per 3 months or per quarter. So if we write out our formula, so I'm just going to plug some things in. So I got my regular payment for R, and I got 1 minus 1 plus my interest rate. So my adjusted interest rate, and then it's to a negative exponent of N, which was 20. Then I have to divide by my I. So try that out. See if you can work your way from the inside brackets out. So do the 1 plus 0.01125, then to the exponent negative 20, and then you take that answer and you subtract it from 1, and then times 750, and then divide it by your interest rate. So what you get is 13,365.34. So that's the present value that you need now in order to pay $750 every 3 months for 5 years. So just an idea to work with, but what we're going to focus on is using the TVM solver. So let's try these where we're doing that. And so it says, solve for the unknown value. The first one says you want to buy a $1,300 computer on credit and make monthly payments over 2 years. If the store is charging you 18% per annum compounded monthly, what will your monthly payment be? So this is actually what your credit card would charge around, is 18%. Stores might give you a bit better deal, but it's often going to be quite a bit. And so compounded monthly, and we want to make, we want to buy a $1,300 computer. So this one's a bit confusing in terms of present value and future value, but I know what they're asking for, which is what's my monthly payment. So what they want is my payment amount. So we're going to look for that. Let's fill in what we do know. If I want the computer now, in a sense, is that they're giving me $1,300. And so because they're giving it to me basically in a computer, I have to write my $1,300 here, and it's going to be positive because I get that money basically as a computer. So it's in my hands. So that's my PV, and in the end, I want to have this thing paid off, and for almost all of these, your future value is going to be 0. And so at the end, there's nothing left to pay off, and then these guys are always 1. So let's plug in what else we know. We know the interest rate is 18%, but it's going to be per month because it's compounded monthly. So I need to divide by 12, and you can put that into your calculator just like that, and it'll do it for you. And then N, which is my years times compounds per year, it's over 2 years. So I've got 2 times 12, just like that. And so if you punch that in, you get a PMT value. I believe it'll be a negative because you have to pay them, $64.90. So therefore, the monthly payment is $64.90. So we don't need the negative in our answer because we know we're just paying it to somebody. So if you wanted to, you could go further with this question and say, well, how much interest am I paying overall in those 2 years? I want you to think about that for a second. Like, how would you figure out the amount of interest you're paying? You know that your monthly payment's this, but how much money of that is in interest? So one way to figure it out, and hopefully you can get this on your own, but if I'm making $64.90 payments for 2 years every month, then really I'm making 24 payments of $64.90. So I've got my total amount like this. So I've got my payments times the number of payments. And the computers were $1,300, and that's what the loan was originally for. And so if you punch that in, you should get the interest overall that you've paid. And so if you do, you get $257.60. So you can see that if you're going to pay something on credit and it's 18%, and even though it's just for 2 years, you're basically paying, a huge markup fee for just borrowing the money. And this is why it's generally good to either A, get a better interest rate, or B, just don't borrow any money to get something like that. And a lot of people get in trouble as they borrow and borrow and borrow. Okay, let's take a look at the next one. It says Delaney wants to invest some money at 5.5% per annum compounded annually. She would like the investment to provide $1,000 for scholarships at her high school at the end of each year for the next 25 years. So how much should she invest now? So just to clarify, she wants this for $1,000 for 25 years. At the end of the 25 years, that's it. There's no more money left in it. So the future value, again, is going to be zero. So she doesn't think she needs to invest $25,000 because they should be able to make some interest off it in the meantime. So let's plug in what we know. We got this 5.5, and it's each year, so we don't have to divide it by anything. It's just going to be divided by 1, so it doesn't change. Overall, it's for 25 years, so that's that part. And we know that the payment is going to be $1,000. And so this one you could argue that it could be plus or minus, and it'll work either way. But what we need to know is how much is she going to invest now? And it really says that in the question. So my PV there. And these guys are always 1. So if I do that, I get a PV of $13,413.93. So therefore, she needs to invest that amount now. So you can see it's much lower than what the $25,000 would have been if she just said, okay, I'm going to give you $1,000 each year, rather than just giving this kind of endowment or scholarship. So this is kind of how it works. Some people might give money to their former university or school and say, I want this donated out in tuition or something like that. Okay, the next one, I like this one. It says Mario saved $250,000 for his retirement, which he has deposited into an account that earns 7.2% per year. Compounded monthly, plans to make regular withdrawals of $1,800 per month. How many years will his savings last? And so this is an interesting question, because here somebody's got a bunch of money. They know how much they want per month, and they're just wondering how long is it going to last. And so at the end, we're going to have 0 left over. And we know that the payment is $1,800, and he gets that payment. So it's going to be positive. And then the present value we know is this, which he's going to invest. So he's giving it to somebody, so that's going to be negative. Then we've got our interest rate, which is 7.2. And again, it's compounded monthly, so dividing by 12. And what we're looking for here is N. So the amount of time it's going to last, and then these guys are just 1 and 1. So punch all of that in, and we get an N value of approximately 299.5. And ask yourself, what's the units here? And remember, it's always going to be whatever the compounds are. So I've got this in months. So if I take that and I want to get it in years, I can just say, okay, I'm going to take that to divide it by 12. to get it in years. And so it works out to approximately 24.9 years, or almost 25 years. So his savings basically last that amount of time, and he can pay himself the $1,800 a month. So therefore, his savings will last approximately 25 years. Almost. Okay, so why don't you give these a try? I'm going to take them up right now, actually, but give them a try and then pause the video and see if you can get these. So I'm just going to put in some answers here first, just to speed it up. So the first one, just to talk about it for a second, at the end of every month, Will deposits $150 in an account that compounds monthly. Determine the amount of interest he will earn after 7 years. So this one, I threw this in because you need to decide if it's present value or future value. And so if you look at it, in this case, my PV is 0, and we want to find the future value. So we want to determine the amount of interest. So first we need to find the amount at the end of this investment. So that's my future value. So my payment is going to be minus 150. So if you punch that in, you get a future value of 15,187.29. So what we got to do is find the amount of interest. And I always think, try to think of this logically. If he's making a payment of $150 for 7 years and 12 months, or 7 years and 1 month, or each month rather, so 12 times per year for 7 years, that means he's making a lot of payments. And so that's where we have to think of our interest earned as the end amount, the future value, minus the payment times n. So if I plug that in, so my payment here was $150. Again, we don't want the negative with it, otherwise that would cancel out the other negative. The negative is only involved in that program, which is an odd thing. And then I want to take 7 times 12, which comes out to 84. So if you punch all that in, you end up with 2,587.29. So that's the amount of interest over the 7 years. So therefore, he earns that amount in interest. Okay, the last one here says Megan's going to buy a house worth $500,000. She takes out a loan called a mortgage at a rate of 3.5% per annum compounded monthly that's amortized over 25 years. That's a special way of just saying the loan is going to last 25 years and then it becomes 0. So basically, you're going to pay it off over 25 years, which is a common length of time to pay off a mortgage. It becomes 0 after 25 years is what it's saying. So it says, how much is her monthly payment going to be? So this is a great question. You could go out to buy a house. You might have a down payment, but you basically have to figure out how much you're going to have to pay each month. And the bank will help you with that, but it's nice to go around and be able to figure this out on your own. So if you do this, so we've got 25 years. It's going to be monthly payment. So I multiply it by 12. And then my interest rate is 3.5%. And I need to divide it by 12 to get it per month. And the present value, she's taking out a loan, so she doesn't have this money. So the bank here, actually, you can think of this as positive. The bank's giving her the money. And then she's going to make a payment back. And so the payment will be negative. So if we do this, what we want to find is at the end, she's paid it off. So we want the payment amount. So if you plug all of that in, it's about $2,500 a month. So therefore, the monthly payment $2,503 And then the last one is how much interest did she pay? And this is going to shock you about how much you have to pay in interest on a house. So keep in mind the house is $500,000, just paying it off in 20 years, which is a common length of time. So you get payment times N. That's going to be the amount of money she's actually put towards this house. So the $2,500 times the 12 times 25. And then we subtract what the original amount was for the loan, which is $500,000. So if you do that, we've got 2,503 times 25 times 12. And so I'm just going to move this over here. And so this comes out to $250,936. So this is the amount of interest paid over 25 years. And a lot of people, when they see this for the first time, are just completely shocked. But in the end, after the 25 years, at least this has been the case in the past, is your house is worth much more than you originally paid for it. And so in some ways it's a bit of an investment. And the alternative is that you are renting for potentially the same amount, and it's not accumulating any wealth, and it's just going away to somebody else. So generally it's a good investment, even though you have to pay so much money on it. And a lot of people say, well, I'm just not going to get a loan then, a mortgage. But that's pretty tough to do. Okay, if you have any questions, let me know. So make sure you try these